Cut the torus once and deform it into a cylinder. Cut it again and open it into a square. This square is a fundamental domain for the Flatlanders' universe. We now see their universe using only 2 dimensions. The Flatlanders can still travel about their universe as before. When looking at a fundamental domain, we must imagine that its edges are glued together. Anything leaving one glued edge returns at the other. The way we glue them determines the shape of the space. What do the Flatlanders see in this universe? Their line of sight travels around the universe, and they see the back of their own spaceship. Like the Flatlanders themselves, their line of sight can't leave their 2-dimensional space. They see what appears to be a copy of themselves. Indeed, they see images of themselves in many directions. This tiled picture shows what the Flatlanders see, and that their universe is boundless. They'll never reach an edge. Now the space has no boundary, and the ship can travel in any direction. This space is called a 3 torus. Let's ride the spaceship inside the 3 torus. Even though the 3 torus is finite, we have the illusion of flying in an infinite space. There are only 2 stars in this universe, but we see each one over and over. This isn't the only possible shape for space. Before we visit another 3D universe, we'll look at the corresponding 2-dimensional space. Its fundamental domain is again a square. This time we glue the left and right sides with a flip. This surface is called a Möbius strip. When the spaceship takes a trip around, it comes back upside down. The flip makes a difference in the shape of space. A second trip restores it to its original condition. Let's watch the trip again on the original square. Now glue the top and bottom of the square with no flip. What do the Flatlanders see in this space? Looking up, they see the bottom of their own spaceship. Looking forward, they don't see their ship right in front of themselves because of the flip. Their line of sight keeps going across the bottom. When it wraps around a second time, it's flipped again, and they finally see the back of their own ship. The Flatlanders have the illusion of seeing a reverse copy of their universe, followed by a regular one. They see infinitely many images of their universe, half reversed and half not. What if we do this in 3D? 2 pairs of faces connect as in the 3 torus. To make the flip, connect the top of the right face to the bottom of the left face and vice versa. After one trip, the spaceship appears mirror reversed. After a second trip, it returns to its original state. Let's see what this space looks like from the inside. As in 2D, we see infinitely many images of our ship. Half are mirror reversed, half are not. When we roll, our reversed images roll in the opposite direction. Life in this space is different than in the 3 torus, where all the copies of the ship move in the same direction, like a flock of birds. We fly this way and see ships in neighboring rows flying in the opposite direction. The mirrored images turn, as we do, to fly along paths that seem to cross ours, but they can never hit us. That's impossible in this space. We've looked at only a few of the many possible shapes for space. There are other ways to glue the walls of a cube together. Or instead of a cube, we could use a different shape for the fundamental domain.